Welcome. In this video, we are going to discuss three major intermolecular forces. And intermolecular forces are the attractions that occur between two different molecules. So if we have molecule A and molecule B, the attraction between them is what an intermolecular force is. So the first major type of intermolecular force is a London dispersion force. And what exactly is that? It's basically a short-lived dipole moment that randomly occurs. So, in the universe, we have random molecules just floating around, and from time to time, these molecules become neighboring, and they bump into each other, they get near each other. So, say this end of this molecule is positive, and this end is negative, partially negative. If this molecule approaches this molecule and they are near each other, then this molecule will transform this end of this molecule to be a partially negative. And we're going to have a London dispersion force over here. Because this side is partially negative now, this side will become partially positive. And if we see which is the closer neighboring molecule, that would be this one. So now it's going to transform this end into a partially negative end, which is going to transform this end into a partially positive end. And it's just going to keep occurring like that randomly as molecules bounce around, get near each other, neighbor each other. And that's what makes it very rapidly changing and shifting as well. And that makes these forces extremely weak, especially because they only occur when two molecules are close enough to each other. The next kind of intermolecular force is a dipole-dipole force. And this is extremely similar to the London dispersion forces, except they are not so short-lived. It's not as random as a London dispersion force. These forces occur between polar molecules, which arrange themselves so their partially negative end is close to the partially positive end of another polar molecule. So let's look at an example. Say we have water. Water is a polar molecule, as O is more electronegativity than H, and the O will have a partially negative end, and both H's will have a partially positive charge. And we have another polar molecule, which we'll just have it be water again. So the dipole-dipole forces will occur between the partially negative end and the partially positive end of another molecule. So it will occur between the O and H over here, and say we have another molecule of H2O. It'll occur between H and O. Sorry, that should be negative. And it's just going to keep going like that, and that's how it works. And this is stronger than a London dispersion force, even though it's very similar, because they have greater strength and they have greater permanence. They're not so random and short-lived the way London dispersion forces are. The final kind of intermolecular force is hydrogen bonding. Hydrogen bonds only form between H and highly electronegative elements. And the most electronegative elements on the periodic table are F, O, and N, fluorine, oxygen, and nitrogen, or phone. And these highly electronegative elements, such as F, O, and N, carry a lot of, basically all of the electron density from the H. So if we have H bonded to F, that F is going to take most of the electron density, as we can see over here. And that means that there's not really a sharing or transfer of electrons, which leads us into a trap. Why is it called H bonding? The thing is, it's not really a bond. It's called H bonding, but it's not really a bond because there's really no sharing or transfer of electrons occurring. So just remember that. It's an intermolecular force, not a bond. And it is the strongest kind of intermolecular force because of how much strength that the electronegative element has when it's attracting the hydrogen. And that makes it extremely hard to break a hydrogen bond which gives them extremely high boiling points as well. So this is the most basic version of the three intermolecular forces and their varying strengths and how they occur. Hope that helps.